We're going to start with question 2. Like I said the last time, we're not going to do every problem. This one says a recipe for cookies is 3/4 of a cup of sugar and 3 cups of flour. It says Josh decides to increase the recipe by using 4 cups of flour. What is the cups of sugar he should use? So in this case, we know cups of flour increased. We need to know what the sugar did. So we're going to use a proportion. I don't like fractions in my proportions, so I'm going to use a decimal. I'm going to change 3/4 to 0.75. So here we have 0.75 of sugar goes with 3 cups of flour. So to remind myself, since it's cups and cups, to remind myself everything, I'm going to put sugar up here on the top at S to represent that everything on the top should be sugar, and an F on the bottom of my proportion to represent the flour. Now, if he wants to have the cookies come out the way they're supposed to, he's going to make sure that they are proportional, increase. He increased the flour to 4 cups. And so here now we don't know how much sugar. So we're going to take 4 times 3/4. And when we take 4 times 0.75, we get 3. We have 3 equals, and then we multiply 3 times x to get 3x. Now, to solve for x, we're going to divide both sides by 3. And so x equals 1 cup. He will need 1 cup of sugar. Let's look at problem 4. Problem 4 is an example of a situation that we're actually looking for the unit rate of how much this is changing. So let's look at how it changes by and see if we can see the pattern. If we subtract 508 from 254, we see that we get $2 or 2.54. I'm talking about centimeters, so it's not $2, pardon me. Okay, and if we subtract these, 762 minus 5.08, we get 2.54. And if we subtract the next one, it would also be 2.54 centimeters for every inch. Now, since y is the centimeters, we would have to multiply this 2.54 times the x to get to the y. And if we look at our choices down here, we'll see that it's true. Well, one way to make sure, because it looks like this one is definitely not the one that works. And this one definitely not the one that works. We're not adding, we're multiplying every time. But the question is, which one we multiply? Well, let's just plug one in to see. Let's try the first one. This says that 2.54, which is y, is equal to, that y is equal to 2.54 times x. In this case, x is 1, so it's 2.54 times 1. Well, you know that 2.54 times 1 is 2.54, so this works. F is the correct solution. We'll do another problem a little bit further down. Number 18. Now on my screen you can't see all of it, but we're going to pay attention to just the different tables so we can make sure. The question does state that it says, which of the following tables is a proportional relationship? Well, there's 3 things that we need to remember for a proportional relationship. 1, it looks like a line when it's drawn. 2nd, it goes up by the same rate each time. And the 3rd, it starts at 0. So the first thing I'm going to look for whenever I'm looking at a table is, does the value start at 0, 0? F does not. F is not proportional. solely on the fact that it does not start at 0, 0. G does not start at 0, 0, so G does not work. H does, so I'm going to skip it so can come back to it just in case, and J does not. So these are not represent proportional relationships because they don't start at 0, 0. This one starts at 0, 0, but we've got to make sure that it does the others. Well, here we go. 16 minus 8 is 8. 24 minus 16 is 8. 32 minus 4 is 8. Sorry. So as we can see that this is changing by 8 every time that this changes by 2. So since that works, this is a proportional relationship. We'll do one more problem. Actually, I think we've got several other problems. Here in the next section it says Tanner completed a scale drawing of his room. Actual room is 18 feet and width is 15 feet. If the width of the scale drawing is 2.5, what should be the length of the scale drawing? So since we're trying to do a scale factor here, we want to try to use proportions. Okay, so what we have is the actual room to the scale drawing. And then we have length to width. Well, we're going to set this up as length is on the top and width is on the bottom. So 18 feet is to 15 feet. Remember, if you need to, you can write little notes of which one goes on the top and the bottom. This is the length to width. Now it says the width is 2.5. So we're going to put the width on the bottom since the width of the other one was also on the bottom. What we don't know is how big that should be. When we cross multiply, we see that 18 times 2.5 is 45. And 15 times x is 15x. We divide both sides by 15 to get rid of the 15, and we see that x equals 3. So the length of the scale drawing should be 3 inches. Make sure I don't skip anything. Okay, going a little bit further down, we have one other problem. Okay, here it gives us the vertices of P, Q, and R. It tells us we're going to dilate it by a scale factor of 0.25. In other words, we're going to multiply every point by 1/4. So we find out what is 1/4 of 2. Well, 1/4 of 2, or 2 divided by 4, is 1/2, or 0.5. And 1/4 of 4 is 1. So our new P is now going to be 1/2, 1. We'll find our new Q. 1/4 of 8 is 2. So the new Q is going to be 2, 2, since 1/4 of 8 is 2 and 1/4 of 8 is 2. And our new R is going to be 1/4 of 8 is 2 and 1/4 of 4 is 1. So our new P, Q, and R, this will be P prime, Q prime, and R prime, will be, and I'm going to use a different color for this, at 1/2, 1, that's the new P prime, 2, 2, and 2, 1. So here we have a triangle that is 1/4, 25% of the original size for P, Q, and R.